All right, today we're going to crack open, it's basically a 2,500-year-old life hack. Seriously, it's like a secret code for understanding the world around us, and it's hidden in plain sight everywhere you look. We are talking about one of the most famous, most important rules in all of mathematics, the Pythagorean Theorem.
So you might be asking, where does this ancient rule even come from? Well, like all the best tools, it was actually designed to solve a puzzle. And this isn't some abstract, dusty old puzzle either. It's one that pops up everywhere. I mean everywhere, from building a shelf in your room to designing the very video games you play. Okay, let's make this super real. Picture this. You've got an 8-meter ladder, you lean it up against a wall, right? And the bottom of the ladder is 3 meters away from the wall. Now here's the question. How far up that wall does the ladder actually reach? How would you even begin to figure that out? See, this is exactly the kind of puzzle that needs a special key to unlock it.
And that key, it's an ancient geometric secret. I'm talking about a rule so fundamental, it has been a cornerstone of math, of engineering, for literally centuries. So what is this big secret?
Well, here it is. The secret is all about right-angled triangles. You know, any triangle that has one of those perfect square 90-degree corners. And here's what it says. If you take the two shorter sides, we call those the legs, and you square their lengths, that number will be exactly equal to the square of the longest side. And that long side has a special name, the hypotenuse. It's always the one across from that 90-degree corner.
And this is what that secret code looks like in math language. A squared plus B squared equals C squared. Now, don't let the letters and numbers freak you out. Those little 2's just mean you multiply the number by itself. That's it. This simple, elegant formula, this is the key to our ladder puzzle. And believe me, so much more.
You know, this isn't just some random rule somebody made up. It's a physical reality. Just look at this visual proof here. It's amazing. If you literally draw a square on each of the 3 sides of a right-angled triangle, the area of the 2 smaller squares, so the yellow and white ones you see, will perfectly, and I mean perfectly, fill up the area of the biggest square, the blue one. It's such a cool and beautiful way to see why the formula works.
Okay, that's enough theory for now. Let's actually put this thing into practice. And we're going to start with the most classic example there is. It's time to master the ABCs of Pythagoras.
All right, take a look at this triangle on your screen. So, we can see the 2 short sides, the legs, are 3 units and 4 units long. But the longest side, the hypotenuse, is labeled x. We need to find its length. So how do we do it? You guessed it, we use the code. Let's just walk through this together, step by step. First, we write down the formula. A squared plus B squared equals C squared. Next, we plug in the numbers we know. So that's 3 squared plus 4 squared equals x squared. Step 3, let's work out those squares. 3 times 3 is 9, and 4 times 4 is 16. Easy enough. Step 4, add them together. 9 plus 16 gives us 25, so 25 equals x squared. And for the final step to find just x, we do the opposite of squaring. We find the square root of 25, and that is 5.
And boom, there it is. The missing side is 5. This right here, this is the famous 3, 4, 5 triangle. It's just a perfect, clean, whole number example of the Pythagorean theorem in action. And I'm telling you, once you see this one, you start spotting it everywhere.
But wait a second, what if the situation is flipped? What if you already know the longest side, the hypotenuse, but you're missing one of the shorter legs? Well, the really cool thing about this theorem is that it's flexible. You can just work it backwards.
Here's the only difference you need to remember, and it's super simple. When you're looking for the longest side, the hypotenuse, you add the squares. But if you're looking for one of the shorter sides, a leg, you just do the reverse. You subtract the squares. You take the long side squared and subtract the short side squared.
Let's check out an example. Here, the hypotenuse is 25, and one of the legs is 24. We need to find that other leg. So what do? We subtract. 25 squared, that's 625. 24 squared is 576. So 625 minus 576, that equals 49. And the square root of 49? It's 7. Bam! The missing side is 7 centimeters.
Okay, so it's a neat math trick, right? But why should you actually care about a formula that's 2,500 years old? Well, let's bring this full circle, back to the real world, and see just how incredibly practical this ancient rule still is today.
Hey, remember our ladder puzzle from the very beginning? Well, now we have the key.
That 8-meter ladder, that's our hypotenuse, or C. The 3-meter distance from the wall, that's one of the legs, A. We're trying to find the height, which is the other leg, B. So this is a subtraction problem. We do 8 squared minus 3 squared. That's 64 minus 9, which gives us 55. Now, the square root of 55 isn't a perfect whole number, but that's okay. It comes out to about 7.42. So there's our answer. The ladder reaches 7.42 meters up the wall. Puzzle solved.
And once you know the rule, you see it everywhere. You can apply this to so many things. That diagonal brace on a garden gate? Yep, that's a hypotenuse. Trying to figure out the height of a tree? Well, if you measure its shadow and the distance from the very top of the tree to the tip of the shadow, you've just made yourself a giant right-angled triangle.
And honestly, it goes way, way beyond the backyard. Architects and construction workers, they use this constantly to make sure their corners are perfect 90-degree right angles. The engine in your favorite video game, it's using this formula billions of times a second to calculate distances between objects. The GPS in your phone that tells you where to go, it relies on these exact same principles. It really is one of the fundamental building blocks of our entire modern world.
So look, if the whole A, B, and C thing ever feels a little confusing, just forget the letters and remember this. Leg squared plus leg squared equals hypotenuse squared. That is all it is. The two short sides squared and added together always equal the long side squared. Simple as that. And that kind of leaves us with a final, much bigger thought. This isn't just a handy formula for calculating one little triangle here and there. It's a universal truth. It describes a fundamental property of space itself, a perfect unchanging relationship that is true for every single right-angle triangle in the entire universe. It's just a cool reminder that underneath all the chaos of the world, there are these elegant, simple rules just waiting for us to discover them. Makes you wonder, what other secret codes are out there?